Okay, I wanted to continue here with class creation. It turns out that I'm working on my own project, which is just a simple class. I was going to use it to show you some facets of interfaces later on. Also, I'm interested in the new Java 8 functional paradigms, and the class was kind of useful for exploring those. So haven't learned all that yet, but I'll show you a little bit of that as a kind of tasty preview here as we get some more experience with the class development in NetBeans. Now, I've already done all this, so I'm just going to roll through the class with you. So I won't go over the mechanics of telling NetBeans to insert the setters and getters and insert the constructor. You can see that in the previous video. Alright, let's end the show. And I think I have NetBeans open over here somewhere. Yep, there we go. So, recall from The Hobbit and Lord of the Rings, the Hobbit smoked pipeweed. So we're going to develop a simple class that we can use to do like a simulation of a Hobbit pipeweed business or some such. And of course, if you want, you're welcome to simply imagine you've been hired by a store owner in Colorado or something like that. So anyhow, pipeweed has the following characteristics. It'll have a name. It'll have a quality, which is an informal number for 1 to 10. So top shelf is 10. It'll have a unit cost, which is a double. It might be dollars and cents. We haven't really specified that yet. And then it'll have a color. And all of these things are private, and then we have the access or the get methods to make them available. So we have get name, get quality, get color, and get cost, and they return the actual value for a given instance of pipeweed, and they have the same type as the values they return. And then the idea is that these things don't change. So once you create a pipeweed object, it's never going to have a change of name or color or quality. The only thing here that might change is the cost. So therefore, the only setter we have is set cost, and then once the user creates an instance of pipeweed, they can't change anything but the cost in it. So if we look here, here's the constructor, and you can see that it just takes those values and then passes them and assigns them. So we'll come back and refine this maybe later on and add different things. I don't think it's going to lend itself to inheritance, and so I really had written it to play with the interfaces and how we could use an interface to specify things like comparison and filters and that sort of thing. Okay, let me show you real quickly what I've done with this. Looks like I have some red ink on there. Did I miss something here? What is that? Oh, okay. They got a little... There we go. Okay, so here's the driver that I wrote to test this out. And again, I'm also pushing some of these new paradigms. I'm not sure how new this is, but it was new to me. So the first thing I want to do is I want to create a list of different kinds of pipeweed called smokes. So here you see final list pipeweed smokes equals arrays as list, and then this is essentially a literal array where I use the constructor of pipeweed to create a bunch of instances of pipeweed objects, all that have different values and characteristics. And you can see that this almost simulates a reading data in from a file. It almost looks like these are comma delimited file things. And we could certainly make that a part of this application at some point. Okay, so what that does is that creates an array list called smokes, which now has all this pipeweed. So like the first element is the long bottom leaf. Its color attribute is brown. It has a quality index of 9 and a unit cost of 400. Okay? Alright, now this is the part you might find interesting, and we'll give just a quick introduction to some of the functional paradigms. So one of the things that I want to do here is I want to iterate through these and display these as a list. So I want to display all the different kinds of pipeweed. And right now we can just be satisfied with displaying the name. So to use the old imperative style, or old Java 7, system out print line imperative, that's just going to print a header. And then we're going to use this for each style of loop to go through the array list. So you can see it's a for loop. It has a pipeweed looping object, and that's going to be one of the entries in smoke. So this says go through all the pipeweed objects in smokes, and each time through, this SM will be assigned to the current one. So this is just like a for loop with an index, but we can do it without an index, and it's more concise. So here, smoke get name is the name of the smoke, and the print line will display it. And so you can see that this SM will take on each of the elements here in the array list. So the first time it'll be the long bottom, then Hobbiton, etc. Okay, so that's straightforward. You should already know how to do that, by the way. Hope that's true. Here's our first functional paradigm. And basically we're going to use the stream on the smokes array list. And this will kind of do the same thing as the iterator, except there's a possibility of parallelizing it, sorry about that, which means the exact opposite of my misnomer there. Anyway, this is going to stream all of the objects in the array list, just kind of like a stream we're used to reading, and then the for each will address them one at a time and apply this function. And notice this function is called a lambda expression. And so this S here is basically just a placeholder variable, a parameter, and the type is inferred. It's going to be the type that's inside the smokes array list. So this S here is actually the pipeweed object. And so really what this says is that for each one of these pipeweed objects, get its name and print that name out on a line. So it does exactly the same thing as this does here, and it's actually not any conciser, although you can argue that in meaning wise it's a little clearer. So stream through all the smokes for each one, print out its name. Kind of looks like regular English. Does this look much different? Yeah, it's a little better. Okay? Alright, let's run this and just take a quick look. It's going to show all the output for the rest of the program too. Let's see. So let's go up to the top. Here's our imperative. So long bottom leaf, Hobbiton, etc. through Brownsville. And then here's our functional, and of course we can see that it's the same. And then the next part of the program actually starts to play around a little bit with filtering and trying to do a match and that sort of thing. So if we come back here, let's see, we have the functional, and so here we have a section that says match a parameter filter. And then so the imperative way to do this is to just put a conditional statement in here. Yes, if the get color is equal to purple, then go ahead and print it out. Okay, so this is going to run through the whole list and only print out the ones that are purple. To do the same thing with the new functional style, again we stream, we use the filter, and here we use the filter to get the color and see if it's equal to purple. So this stream gives everything in the array list. The filter removes everything that's not equal to purple, and then the for each does the get name, print the get name. So that's kind of cool. And you can see we're saving some. It's a little more concise. Again, these are lambda expressions. Should be pretty clear how those work from context there. We'll talk in more detail. Again, I'm still learning a lot about this. So real quickly, I'll just run the rest of this for you. You'll have another example of creating a class. So here where we did the purple test, we got these, and we get the same results with the functional code. Okay, hope this is good for you. Take care.